Hi everyone, this is a new topic titled Thermochemistry. From the name it suggests that it has to do with heat, and we are going to study about the changes in heat energy during chemical reaction. And I believe you have already learned what is an endothermic reaction and exothermic reaction. Just to help you remember easily, endothermic, you can remember it as heat enters the system. So heat energy is taken in or absorbed. Exit, heat energy is given out or released. That's how you can remember. And when heat energy is absorbed, the temperature of the surrounding decreases. And when heat energy is released, the temperature of surrounding increases. Now, these are the examples of exothermic reactions and exothermic processes. In fact, most of the chemical reactions, they are exothermic. And these are the examples that you are familiar with. For exothermic processes, there are a few you have actually learned, like freezing and condensation. I'll explain this in detail in a while. As for the last example, dissolving anhydrous salt in water, this has a common application in our daily life, which is our hot pack. Anhydrous salt, it means salt without water, and when it's dissolved in water, it will release heat, and we can use this for application, for example, in our hot pack. For endothermic reaction, there are only a few. The common ones, they are decomposition reactions, whereby when something decomposes, it absorbs heat. For processes, they are melting and boiling. And for the last one, this part, dissolving ammonium salt, potassium salt, or thiosulfate salt, this process will absorb heat. So again, the reverse of the hot pack is cold pack. So in this case, it will absorb heat, giving a cooling effect. So coming to these two curves that we have learned, melting graph and also freezing, we want to look at this part whereby the temperature remains constant. So during the freezing process, temperature is dropping, but at this point, when it starts to freeze, the temperature remains constant. Why it remains constant? Because this process is actually exothermic. Because as the particles come together, they form a force of attraction, and that process actually releases heat. Now for melting, as temperature increases up to a certain point, which is the melting point, the temperature stops increasing because this process is actually endothermic. Heat is actually absorbed to overcome the force of attraction among the particles. So that's why melting is endothermic. Now let's look at this main part of the lesson, which is heat of reaction. For every reaction, there's actually heat change. We call that heat of reaction. So heat of reaction can either be exothermic or endothermic, but most of the time it is exothermic. Now the symbol for heat of reaction, we use delta H. The unit is kilojoule per mole. We use joule for energy, but in chemistry we use kilojoule per mole. We have already learned what mole is. And for the sign, if the value is positive, it is endothermic. If the value is negative, it's exothermic. We'll look at this in another lesson. We usually express the information of heat of reaction together with chemical equation. So this is a famous chemical reaction. We call it the Haber process, used to manufacture ammonia. And this process is actually exothermic. It releases heat. The negative sign shows that it's exothermic. Now let's look in detail what happens during a chemical reaction that releases heat or absorbs heat. So we will use this example, Haber process, the manufacturing of ammonia. So during a chemical reaction, first thing is all bonds must be broken down. And as we can see, nitrogen, there's a triple bond here. hydrogen, there's a single bond. So during a chemical reaction, all these bonds must be broken down. And after the bonds are broken down, new bonds will be formed. And along the process, when the bonds are broken down, heat must be absorbed to break down all the bonds. And when the bonds are formed, heat is released. So bear this in mind. And there's another thing that I would like to introduce to you. Different bonds, they have different energy content. So in this case, hydrogen, it has this amount of energy content, and likewise for other types of bonds. So we will be calculating the heat of reaction using all this in a while. But let's look how it actually runs during the reaction. So first, we have the ratio is 3 hydrogen molecules to 1 nitrogen molecules. So we have 3 hydrogen bond and 1 nitrogen triple bond. And as we have talked about just now, during a chemical reaction, all bonds must be broken down. So heat is absorbed in this process. So the energy content, heat is being absorbed, so it raises the energy level to a certain level. And we can actually calculate this amount of heat by multiplying this value with the number of bonds we have. So we actually multiply 3 times 436 plus the nitrogen 946, you get this amount of energy. And when heat is absorbed, it breaks down all the bonds, and now we have single atoms. So in the next process, bonds will be formed, and when bonds are formed, heat is actually released, and we can calculate the heat release based on the number of bonds formed. So in this case, it is the nitrogen and hydrogen bond is formed, and we'll get this amount. We will look at the calculations in detail in a while. So the last part is to look at the net difference. So the overall picture, heat release is actually more than heat absorbed. So we can say delta H, or heat of reaction, we use heat absorbed minus heat release. At the end, we get a net difference of a negative value, negative 92 kilojoule per mole. And this net difference shows that it is exothermic reaction because of the negative sign. And so let's look at the calculation in detail once again. First, we calculate the heat absorbed. We have 3 hydrogen bonds, 3 times 4, 36, plus 946 for nitrogen bond. So the heat absorbed is 2254. For heat release, there are 6 nitrogen to hydrogen bond. So we times 6, and we get 2346. And once again, to find the heat of reaction, we use heat absorbed minus heat release. We get a net difference of negative 92 kilojoule per mole. And this shows that it is an exothermic reaction. Just one thing, you do not have to memorize the bond energy. It will be given to you. This reaction is actually reversible. That means from ammonia molecule, it can be reversed back to nitrogen and hydrogen. And we can actually work out the math, similar method. We will get positive 92 instead. So as a summary, for endothermic reaction, heat is absorbed, temperature of surrounding decreases, and the heat of reaction is positive. For exothermic reaction, heat is released, temperature of surrounding increases, and the heat of reaction is negative. So that's all for this lesson.